In this episode, we're going to compare the security posture you can build in Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, GCP, without getting pulled into brand talk or platform fandom. Beginners often hear strong opinions that sound confident, but are usually based on one person's limited experience in one environment at one moment in time. A more useful approach is to look for patterns. What each platform tends to do well, what each platform tends to leave up to you, and where default settings can quietly create exposure if you assume the platform will handle everything automatically. The exam wants you to reason across clouds, and your future work will benefit from that same skill, even if you mostly live in one provider. We'll keep this grounded in security ideas that transfer, like identity, networking, storage access, logging, and configuration guardrails. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful way to compare these clouds is to separate built-in capability from default posture, because those are not the same thing. All three providers offer strong security building blocks, and those building blocks can support very mature defenses when used correctly. At the same time, defaults often prioritize easy onboarding and quick success, which can mean permissive settings, simplified networks, or broadly usable roles that are convenient but risky. That does not mean a provider is unsafe. It means the provider assumes you will make choices, and beginners sometimes do not realize they are making choices. When you compare platforms, you should ask two questions repeatedly. What security feature exists, and what happens if I do nothing? The gap between those two answers is where most cloud incidents are born. Start with identity, because identity is a core strength area across all three platforms, but it is also one of the easiest places to create accidental administrator power. Each provider offers rich permission models that can express fine-grained access, meaning you can define who can do what to which resources under which conditions. That is a big strength compared to older environments where permissions might be coarse and hard to audit. The weak default pattern is that early setups often encourage broad permissions so that services work without friction, and those broad permissions can linger long after the learning phase. Another weak pattern is mixing human and service access in ways that blur accountability, which makes it harder to detect misuse. In other words, the platform gives you a precise steering wheel, but the first setup can still hand you a fast car with the traction control turned off. Now consider how each platform tends to support logging and auditing, which is another area where the capabilities are strong, but defaults can be misleading. In all three, there are ways to record management actions, resource changes, and access events, and those logs can become the backbone of investigations and detections. The strength is that cloud actions are inherently API-driven, which means they can be captured in a consistent, searchable way if you enable and retain the right signals. The weak default pattern is that logging might not be fully enabled, might not be retained long enough, or might not be routed somewhere that people actually review. Beginners sometimes assume logs are automatically collected and protected forever, but in practice you often have to decide what to keep, where to store it, and how to prevent tampering. The real comparison is less about whether logs exist, and more about how quickly a new team can create an audit-ready trail without missing critical gaps. Storage security is another major comparison point, because cloud storage is powerful, widely used, and frequently misconfigured. All three providers offer ways to control access at multiple layers, such as account-level controls, resource-level permissions, and policy mechanisms that can restrict who can read or write. They also offer encryption options that can protect data at rest and in transit, which is a clear strength for confidentiality when used correctly. The weak default pattern is that storage can become publicly accessible through a small number of permission changes that might seem harmless during testing. Another weak pattern is oversharing, where access is granted to large groups or broad identities for convenience, and then never reduced. When you compare providers, the key is that they all allow secure storage, but they also all allow you to publish data to the world if you are not careful, and they make it surprisingly easy to do by mistake. Networking and segmentation show a similar story: strong capability, risky shortcuts. Each platform offers constructs for isolating workloads, controlling inbound and outbound traffic, and creating private network spaces that separate environments. This is a strength because you can build clear trust boundaries and reduce lateral movement opportunities for attackers. The weak default pattern is that initial networks are often created to allow things to connect easily, which can mean broad internal connectivity and permissive outbound access. Beginners sometimes focus only on blocking inbound traffic from the internet, but ignore that outbound traffic can be an equally important control for preventing data exfiltration and limiting attacker command channels. Another weak pattern is allowing management access from wide ranges because it works quickly rather than building a deliberate administration path. Across AWS, Azure, and GCP, the exam-relevant lesson is that secure network posture is rarely the default. It is the result of explicit segmentation decisions. Managed services are one of the biggest strengths of public cloud, and they matter to security because they can reduce operational burden and remove entire categories of patching and maintenance from your responsibilities. When you use managed databases, managed message services, or managed identity integrations, you often inherit hardened operational practices from the provider, which can be a major security advantage. The weak default pattern is that because something is managed, teams assume it is automatically safe in every configuration, and they skip the work of access control, encryption choices, and monitoring. Another weak pattern is misunderstanding what managed means, as if it implies the provider will prevent all misuse, when the provider often manages availability and underlying infrastructure while you still manage identity, data, and exposure. This is where vendor blind spots grow, because marketing language can make managed services sound like security solutions. The calm comparison is that all three providers offer strong managed services, but none of them can compensate for poor permission design and careless exposure decisions. Encryption is often discussed as if it is the defining security feature of a platform, but in reality, encryption is a shared strength across the major providers and rarely the deciding factor by itself. Each platform supports encryption for stored data and network traffic, and each offers ways to control keys and key usage policies. That means you can build systems where data is protected in expected states, and you can also design higher assurance key management patterns when needed. The weak default pattern is assuming that encryption alone solves data exposure, when access control failures still allow authorized identities to retrieve decrypted data through normal service interfaces. Another weak pattern is leaving key management choices unexamined, such as who can use keys, who can rotate keys, and who can disable key protections. Across AWS, Azure, and GCP, the exam-relevant view is that encryption is a necessary control, but it is not a substitute for careful identity and policy boundaries. Account and project organization is another area where the platforms are similar in spirit but different in terminology, and what matters for security is the boundary behavior those constructs create. Each provider supports separating environments, limiting administrative scope, and isolating resources so a mistake or compromise in one area does not automatically spread everywhere. This is a strength because you can reduce blast radius by design, which is one of the most effective strategies in cloud security. The weak default pattern is starting with a single broad environment and continuing to add resources to it because it is easy. Another weak pattern is sharing administrative identities across boundaries, which defeats the purpose of having boundaries in the first place. When you compare clouds, the most important point is not which word they use for these boundaries, but whether you can design clear, enforce separations that are easy to understand and hard to bypass. Default access behaviors deserve special attention because defaults shape the culture of how teams build systems. A common default weakness across clouds is that early-stage setups are optimized for speed, and speed often means more permissive access than you would choose in a mature environment. This can show up as wide-reaching roles, broadly reachable endpoints, or default network paths that assume internal trust. Another common weakness is that certain protections are available but not enforced unless you choose them, such as additional checks on risky actions or stronger restrictions on public exposure. Beginners sometimes interpret available as enabled, and that misunderstanding can lead to a false sense of safety. The calm way to think about defaults is that they are training wheels for adoption, not a security baseline for production. If you treat defaults as the starting line rather than the finish line, you will naturally look for what must be tightened. Another useful comparison angle is how these platforms support policy guardrails, meaning centralized ways to enforce consistent rules across many teams and resources. This is a strength because cloud environments grow quickly, and human review alone does not scale well when hundreds or thousands of resources exist. Guardrails can prevent certain risky configurations from being created, or they can detect and flag them quickly, which reduces exposure time. The weak default pattern is that guardrails are often optional, and organizations adopt cloud faster than they adopt governance, creating a long period where teams have freedom but little oversight. Another weak pattern is creating guardrails that are too broad or too strict, leading teams to look for workarounds rather than cooperating with security goals. Across providers, what matters is that guardrails exist, can be centrally managed, and can be aligned to the shared responsibility model so that security rules are enforced where the customer actually has control. A common beginner question is whether one of these clouds is simply more secure than the others, and the calm answer is that secure outcomes depend more on how you use the platform than on which logo is on the documentation. Each provider has excellent security engineering and invests heavily in protecting the underlying infrastructure. Each provider also offers advanced features that can raise your assurance when you configure them well and operate them consistently. At the same time, each provider exposes enough flexibility that you can make serious mistakes, especially around permissions, public access, and unmanaged secrets. If you pick a platform and assume it will solve security for you, you are likely to create exposure. If you pick any platform and apply strong principles, you can build a resilient posture. That mindset helps you avoid vendor blind spots and keeps you focused on transferable security thinking. It also helps to compare how incidents typically happen in these environments, because incident patterns highlight where defaults and human behavior interact. Many cloud incidents start with credential exposure, such as a leaked access key, a compromised user account, or a mismanaged service identity. From there, the attacker explores what that identity can access, and if permissions are broad, the attacker can often escalate impact quickly. Another common pattern is accidental public exposure, especially with storage and services that were meant to be internal, and that exposure often persists because teams do not have strong monitoring for it. A third pattern is configuration drift, where an environment starts secure but becomes less secure over time due to changes made in a hurry. None of those patterns are unique to one provider, and that is the key comparison lesson. The same risk stories repeat across AWS, Azure, and GCP because the underlying cloud model is similar. As we close, the best way to compare these platforms for the exam is to hold two truths at the same time without letting them contradict each other. First, AWS, Azure, and GCP each provide strong security capabilities that can support serious defenses, including fine-grained permissions, segmentation options, encryption support, and audit logging. Second, their default and early adoption experiences can create weak postures if you assume convenience defaults are production-ready and if you delay governance until later. When you evaluate strengths, look for what can be enforced, monitored, and scaled reliably. When you evaluate weak defaults, look for what becomes public too easily, what becomes over-permissioned too easily, and what fails silently when logging and reviews are not set up. If you keep this vendor-neutral map in your mind, you will be able to answer comparative questions calmly, and you will be able to spot the same security truths no matter which cloud vocabulary is used.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.